Have you ever, stopped to think about what really goes on when you tap an app icon or click a link?
Yeah, it just works, right?
Exactly. It feels so effortless. Information just appears, things happen, you connect. But behind that smooth surface, there's this whole hidden world. A universe of code and data working together.
It really is like an invisible dance, isn't it? What feels almost magical to, the person using it is actually this incredibly complex orchestration of technologies, all working in sync.
Absolutely. And that's precisely what we're pulling back the curtain on today, our mission for this deep dive to unpack this complex world of full stack development. We've got a great thread of sources here, and the goal isn't just to list the pieces, but really explore how they fit together, why they matter.
Right, the connections.
Yeah, hopefully you get some real aha moments.
Yeah.
Because by the end of this, you should have a kind of shortcut to understanding this whole ecosystem of how modern software gets built.
That's the idea.
Yeah.
Yeah. At its core, full stack development is really about building a complete software application, start to finish.
Okay.
It's not just mastering one thing, but understanding and being able to work across that whole spectrum of technologies.
So let's break this down then. Our sources point to three main foundational layers. Absolutely crucial for any web application.
Right.
First up, the front end. That's everything you actually see and interact with.
What's on the screen?
Exactly. Then there's the back end, the sort of invisible engine making it all tick.
The brains.
And finally, the database, which is basically the application's memory, where everything gets stored long term.
And it's worth mentioning, too, our sources also bring in DevOps. That's all about automating how apps are deployed and run and mobile app development. They're often seen as part of, or at least very close to, the full stack skill set.
Okay, good point. We'll definitely get into those as well to give you that complete picture.
Sounds good.
All right, let's start where you, the user, start. The front end, the user's world.
Makes sense.
This is literally everything you see, everything you touch, digitally speaking, in your browser. One source had a great analogy, like the storefront, the interior design, and the customer-facing employees of a shop.
Oh, I like that. Yeah, it's where the visuals meet the interaction.
So how do you build that storefront?
Well, you start with the absolute fundamentals of the web. First, there's HTML, hypertext markup language.
Right.
That defines the basic structure, the skeleton, really. Your headings, your paragraphs, images, links. It tells the browser what content to show.
Just the raw stuff.
Pretty much. Then you need to make it look good, right?
Right.
That's CSS, cascading style sheets.
Okay.
If HTML is the skeleton, CSS is the stylist. It controls how everything looks, the colors, the fonts, the layout, the spacing. It tells the browser how to display the content.
So HTML is CSS is the how it looks.
Exactly. But it's still static at this point. To bring it to life, make it react. When you do something, you need JavaScript.
JS. Ah, the magic part.
Sort of. It handles all the interactivity. You click a button, JavaScript handles that. Submit a form, JavaScript. See content update without the whole page reloading.
Yeah, that smooth feeling.
That's JavaScript. It's what makes the page dynamic and responsive to you.
You know, learning about HTML, CSS, JS, that makes sense. But the real kind of aha moment for me was realizing that building a modern, complex app with just those basic tools,
Yeah.
it's like trying to build a huge building with just loose bricks.
Yeah, it gets messy fast and slow.
Incredibly messy. And that's where frameworks come into the picture, right? They provide the structure, the reusable parts, the sort of architectural plan.
Exactly. They provide the scaffolding, pre-built components, best practices.
Right.
It makes building robust, complex front ends actually feasible and efficient.
So when people talk about front-end development today, you always hear about the big three JavaScript frameworks or libraries, React, Vue, and Angular.
Those are the main players.
They all have this idea of breaking the UI into reusable components, right? Like a button or maybe a user profile card that you can use in multiple places.
Precisely. That component model was a huge leap forward. It makes code much more organized, manageable, and faster to develop. Plus, they're really good at updating only the parts of the page that change, which gives you that smooth, fast user experience.
What's interesting, though, is that they aren't all the same. Like React, which came out of Facebook, it seems very flexible, massive community, lots of options.
Yeah, React gives you a lot of flexibility. It's technically a library, not a full framework, so you often piece together other tools with it. Great for complex apps where you want that control.
And Vue, I hear that's maybe easier to pick up.
Vue is often praised for its Gentler learning curve and really clear documentation. It strikes a nice balance, maybe great for smaller teams or projects where you want to get moving quickly.
Okay. And Angular from Google. That sounds more like a complete package deal.
Angular is definitely more of a full opinionated framework. It provides a lot out-of-the-box routing, state management, tooling. Enterprises sometimes like that structured approach for consistency across large teams.
Gotcha. Now, with all these JavaScript files, CSS files, modern apps can have hundreds, right? How does the browser handle all that efficiently?
Yeah, that's a challenge. That's where tools like Webpack come in. It's called a module bundler.
Okay.
Think of it like a super smart packer. It takes all those individual JavaScript files, CSS files, even images sometimes, optimizes them, and bundles them into just a few small, efficient files.
So the browser only has to download a couple of things instead of hundreds.
Exactly. Makes the initial load much, much faster for the user.
And for styling quickly, without writing every single line of CSS.
Right, you've got UI component libraries like Bootstrap or Material UI.
I heard of Bootstrap.
Yeah, they're super popular. They give you professionally designed, pre-built components, buttons, forms, navigation bars, grids, all ready to use.
Like pre-made furniture for your website shop.
Perfect analogy. It dramatically speeds up development and ensures everything looks consistent and modern without you having to be a, top-tier designer yourself.
Okay, that makes a lot of sense for the front end. Moving behind the scenes then, we get to the back end.
The engine room.
Yeah, the server side. The invisible part that makes everything actually work. The source analogy was the kitchen and warehouse of our shop.
Love it. Yeah, it's doing all the serious work away from the customer's view.
So it's not just about showing things, it's about doing things. When I click buy, the back end handles the order, checks inventory, processes payment.
Exactly. It handles all the business logic, processes your requests from the front end, talks to the database to get or save information, and then sends the right data back to the front end to display. It's the brain, really.
So for someone listening, maybe thinking about building something,
Yeah.
what's a common misunderstanding about what the back end actually does and what tech runs back there?
Good question. I think a common misconception is that it's just storing data, which it does, but it's also doing calculations, handling security, managing who's logged in, integrating with other services like, say, sending emails or processing payments.
All complex rules.
All the rules, exactly. As for technologies, there are several heavy hitters, each with strengths.
Give us the tour.
Okay. Python, often using frameworks like Django or Flask, is incredibly versatile and known for being readable, used for web stuff, but also data science, AI.
Right. Python's everywhere.
It really is. Then there's Node.js. Now, this is interesting. Node.js isn't a language itself. It's a runtime environment, meaning it lets you run JavaScript the same language you use in the front end on the server.
Oh, wow. So one language for both front and back.
Potentially, yeah, which can be really efficient for development teams. Node.js is particularly good for applications that need to handle lots of simultaneous connections quickly, like chat applications or real-time dashboards.
Okay, cool. What else?
We've got Ruby on Rails, famous for enabling really rapid development. It has this philosophy of convention over configuration.
So it makes assumptions for you.
Kind of, yeah. Smart assumptions about how you'll structure things, which means less setup boilerplate code, more time-building features, like a well-designed recipe, maybe?
I like that. What about big companies?
For large enterprise-scale applications, you often see Java with the Spring Framework. It's known for being very robust, high-performance, stable, and scalable.
Right. Java's been around a while. Very solid.
Very solid. And if you're heavily invested in the Microsoft world, there's ASP.NET, usually using the C# language. It's a powerful framework, especially within the Windows ecosystem.
Okay. And you mentioned sometimes the backend needs an extra speed boost, something faster than the main database.
Yeah, absolutely. That's often where something like Redis comes in.
Redis.
It's an in-memory data store, which basically means it keeps data in the computer's RAM, not on the slower disk drives.
So lightning fast.
Incredibly fast. It's not usually the main database, but it's very commonly used as a cache.
A cache. Like temporary storage.
Exactly, for data that's accessed really frequently. Instead of hitting the main database every time, which can be slower, the backend checks Redis first. If the data's there, boom, super fast response. It saves a lot of load on the database. It can also be used as a message broker, helping different parts of the system communicate quickly.
Like a super fast scratch pad.
Perfect way to put it.
All right, so backend handles the logic. Redis gives it a speed boost. Now, where does everything get stored permanently? The application's memory, the database.
the filing system.
This is where all that persistent data lives, right? User accounts, product info, blog posts, comments,
Yeah,
anything that needs to stick around.
correct. If it needs to be saved after the user closes the browser, it goes in the database.
So what kinds of filing systems, databases, do we typically see?
Well, the traditional kind, still very widely used, are relational databases.
Yes.
These store data in a really structured way. Think tables with rows and columns, almost like Excel spreadsheets.
Right. Very organized.
Very organized, and they're great at defining clear relationships between tables. Like a user table might be related to a posts table, showing which user wrote which posts. MySQL and Postgres are probably the most popular open source relational databases. Super reliable, standard choices. They enforce consistency really well.
But not all data fits neatly into tables like that, does it? Sometimes it's messy or changes a lot.
Exactly, and that's where NoSQL databases come into play.
NoSQL, meaning not only SQL.
Precisely. It doesn't mean no SQL ever, but rather that they offer alternatives to the rigid, table-based structure of relational databases. They're generally more flexible.
Okay. So when would you use one?
Often for very large-scale applications, or when you have data that doesn't have a fixed structure, or maybe when your main priority is super high speed and availability, even if it means slightly less strict consistency.
So different types of NoSQL then.
Oh yeah, several kinds. Document databases like Mongo or CouchDB are really popular. They store data in flexible, JSON-like documents.
These are like JavaScript objects.
Exactly. So developers using JavaScript often find them very intuitive to work with. Great for, say, product catalogs, where items might have different attributes, or user profiles with nested information.
What about really massive scale, like Facebook scale?
For that kind of extreme scale and high availability, you might look at something like Cassandra. It's a wide column store, designed to run across many, many servers and handle enormous amounts of writes very quickly. Think sensor data, user activity logs.
Okay. And what if search is really important, like searching products on an e-commerce site?
Then you probably use Elasticsearch. It's fundamentally a powerful search engine.
So not just storing data, but indexing it for fast, complex searching.
Exactly. It's brilliant for implementing features like auto-suggest, faceted search, or even analyzing large volumes of log data to find specific errors quickly.
Fascinating. And there's another type, graph databases.
Yes. Graph databases like Neo4j or ArangoDB. These are really cool because they're specifically designed to store not just the data points, but the relationships between them as first-class citizens.
So the connections are key.
The connections are just as important as the data itself. Think about social networks, who's friends with whom, or recommendation engines, people who bought this also bought that, or even fraud detection linking suspicious activities together. Graph databases excel at querying those relationships very quickly.
Wow, okay. So many different ways to store data depending on the need. Now, beyond storage, you mentioned systems helping different parts of an application talk to each other.
Right, especially in larger, more complex applications that might be broken down into lots of smaller, independent services, sometimes called microservices. You need a reliable way for these services to communicate without being tightly coupled. That's where message queues come in.
Message queues,
Uh-huh.
like a digital post office.
That's a great way to think about it. A service can send a message, a task, some data to the queue, and another service can pick it up and process it when it's ready. So they don't have to talk directly.
Exactly. It decouples them. If the receiving service is busy or temporarily down, the message just waits safely in the queue. This makes the whole system more resilient and scalable.
What are some examples?
Well, you have systems like Kafka, which is really powerful for handling high volumes of real-time data streams, like processing click data from a website or sensor readings. Then there's SQS, which is Amazon's managed queue service, very reliable for decoupling tasks between microservices in the cloud. And there are lighter options too, like ZeroMQ for more direct high-performance messaging between processes, different tools for different communication patterns. Okay, so we've got the front end designed, the back end logic built, the database storing everything. How do we actually get this application out to users and keep it running smoothly, day after day?
Now we're entering the realm of DevOps.
DevOps. The source described this as the factory assembly line, quality control, and global logistics for your application.
Yeah, that captures it pretty well. DevOps isn't really just one tool. It's more of a culture, a set of practices that brings together software development, dev, and IT operations.
And the goal is?
The main goal is to shorten the software development lifecycle, to be able to build, test, and release software faster and more reliably. Continuous delivery, basically.
Okay, so what are the key pieces here? Infrastructure seems like a big one.
Definitely. When a user tries to access your app, their request usually hits a web server first. NGINX is a super common high-performance web server,
Right.
but it often does more than just serve files. It frequently acts as a reverse proxy or a load balancer.
Load balancer.
Yeah.
Meaning it spreads the traffic out.
Exactly. If you have multiple backend servers running your application code, the load balancer distributes the incoming user requests evenly among them, so no single server gets overloaded, which improves performance and reliability.
Makes sense. And these servers, people aren't usually running them in their own basement anymore, right?
Haha. Generally not for anything serious. That's where cloud providers like AWS, Amazon Web Services, or Azure, Microsoft Azure come in.
The cloud.
Yeah. Instead of buying and managing physical hardware, you essentially rent computing power, storage, databases, networking, all sorts of services from these providers on demand.
So you can scale up or down easily.
Massively scalable and flexible. Huge advantage. And for keeping an eye on everything, making sure it's working, finding problems, you need monitoring and logging. The ELK stack is a popular combination for this.
ELK.
Stands for ElasticSearch, we mentioned that for search, Logstash for collecting and processing log data from all your servers and applications, and Kibana for visualizing all that data on dashboards.
Yeah, so you can see what's happening, spot errors, track performance.
It gives you visibility into the health of your system.
What about the automation side, making releases smoother?
That's a huge part of DevOps. You'll hear the term CI/CD.
Continuous integration, continuous deployment.
That's the one. Continuous integration means developers merge their code changes frequently, and each time they do, an automated process builds the application and runs tests. Tools like Jenkins are often used for this.
So you catch problems early.
Immediately, ideally. Continuous deployment takes it a step further. If the build and tests pass, the changes can be automatically deployed to production, or at least to a staging environment.
Wow, fully automated releases.
That's the dream. And to make sure all your servers are configured exactly the same way consistently, you use tools like Ansible or Chef.
Configuration management.
Right. You define the desired state of your servers in code, and these tools ensure the servers match that state. No more manual setup errors.
Okay, now there's one area here I find really revolutionary. Containerization. Especially Docker and Kubernetes.
Ah, yes. Game changers.
Docker seems to solve that age-old developer problem. Well, it works on my machine.
Oh, the classic. Yes, Docker tackles that head-on. It lets you package your application along with all its dependencies, the code, the runtime like Node.js or Python, system tools, libraries, everything it needs to run into a single, isolated unit called a container.
So it's like a self-contained box for your app.
Exactly. And that container will run exactly the same way, whether it's on a developer's laptop, a testing server, or in production in the cloud. Consistency and portability solved.
Brilliant. But what if you have lots of these containers? Like hundreds or thousands for a big application.
That's where Kubernetes, often abbreviated K8s, comes in. It's a container orchestration tool.
Orchestration. Like a conductor.
Pretty much. It manages large clusters of servers running Docker containers. It handles things like automatically scaling the number of containers up or down based on traffic, restarting containers if they fail, managing how containers talk to each other over the network.
So it manages the whole fleet of containers.
It makes running complex, containerized applications at scale actually manageable. It's become the industry standard for this.
Okay, wow. That's a whole world in itself. Finally, let's bring it back to the device in your hand. Mobile app development.
Right. Building apps specifically for smartphones and tablets.
This is different from web apps, right? Because you're tapping into device features more directly.
Often, yes. You might need access to the camera, GPS, accelerometer, push notifications, offline storage. Things that native mobile apps handle really well.
So how do people build these? Is it one app for all phones?
Well, there are different approaches. One popular way, especially for efficiency, is cross-platform development, meaning you write your code once using a specific framework, and then you can deploy it as a native app on both Android and iOS.
Ah, saves building two separate apps.
Exactly. Big time and resource saver. Frameworks like React Native let you use React and JavaScript. Ionic often uses web technologies like Angular, React, or Vue. Xamarin from Microsoft lets you use C#. They all aim for that write once, run everywhere goal, or close to it.
What about PWAs, progressive web apps?
Yeah. PWAs are interesting. They're essentially modern web applications built with standard web tech, but they have extra capabilities.
Right.
They can be installed on your phone's home screen, they can work offline to some extent, and they can receive push notifications. So they feel a lot like a native app, but they're delivered through the web, bypassing app stores.
So kind of a hybrid approach.
Sort of, yeah,
Yeah.
blurring the lines between web and native.
But sometimes you need the absolute best performance or access to every single new feature of the platform immediately.
Right. In those cases, you go with native development.
Building specifically for one platform.
Exactly. Using the platform's official languages and tools. For Android, that's typically Java or increasingly Kotlin, using Google's Android SDK.
Okay.
And for iOS, for iPhones and iPads, you'd use Objective-C, though less common now, or more typically Swift, using Apple's development tools like Xcode.
And the advantage there is maximum performance, best user experience, direct access to all device features.
Usually, yes. You get the tightest integration with the operating system, but
But you have to build and maintain two completely separate code bases.
that's the trade-off. Speed and efficiency of cross-platform versus the power and polish of native.
It really is a trade-off, isn't it?
Always is in tech.
So, wow. We've gone from the pixels you see on your screen,
Yeah.
dug down through the back-end logic into the database's memory, looked at how it's all deployed and managed with DevOps on servers, maybe in the cloud, and then right back into the app in your hand.
It's quite the journey.
It really highlights how full-stack development isn't just one thing, but integrating all these incredibly diverse layers, these specialized tools, into something that actually works. A cohesive whole.
Yeah, it's an entire universe humming away beneath that simple interface you interact with.
Understanding these components, even at a high level like this, really gives you that comprehensive view of how software gets built, how it gets delivered, how it stays running.
Absolutely. It's a complex dance, like we said at the start, but every single piece, from the CSS styling your button to the Kubernetes cluster managing the servers, plays a vital interconnected role, all to bring that software to life for you, the user.
So as you think about this incredible modularity, all these specialized tools working together, here's something to chew on. Given this constant innovation, what could be the next frontier? How might we build and interact with software beyond the screens and devices we use now? What kind of new stacks, new layers of technology might emerge when we start applying these principles, front-end, back-end, data, ops, to totally new paradigms like truly immersive virtual reality, or maybe even bio-integrated computing, where the interface isn't a screen at all? What does that stack look like?
That's a fascinating thought to end on. Where does the stack go next?